Good morning, good afternoon, or good evening, depending when you're watching this, students. We are today going to be talking about logic fallacies in research. So this lecture will focus on discussing common types of logic fallacies that people make when consuming research. So let's get to it, shall we? So as we discuss this kind of logistical fallacies that happen inside research, we have to understand that the common fallacies that occur when interpreting research, we first need to define logic fallacies, right? Or logic fallacy. Logic fallacies are common errors in reasoning that makes an argument appear strong or appear stronger than it really is. Now, this can happen when research is interpreted and cause us to believe in the findings of the research more strongly than we should. It is important to learn about these logistical or logic fallacies so we can be aware of them when we're reading research and make sure that we are not falling prey to these common errors in reasoning. There are several types of logic fallacies that we will discuss, and in relation to research. These types include appeal to ignorance, false dichotomy, slippery slope, circular argument, hasty generalizations, causal fallacy, and appeal to authority. And it's important to think about these. I cover a lot of these inside of different classes, but here we're focusing primarily on research. So as mentioned, these are the areas we'll be looking at. Appeal to ignorance, false dichotomy, slippery slope, circular argument, hasty generalizations, cause fallacy, and appeal to authority. So let's jump on into it, shall we? So the first type of logic fallacy that occurs with research is known as the appeal to ignorance. This logical fallacy argues that something must be true because it has not been proven false, or because there is not evidence against it. You'll see a lot of this in folks like Charlie Kirk and people who go on TikTok and use debating methods. This argument happens with research when we think about whether the hypothesis for the research was supported or not. When we do research, we use something called a null hypothesis. In a study, a null hypothesis is the hypothesis we hope to disprove. For example, if I was to conduct a study on favorite colors, I might predict that most common favorite color is purple. In this case, the null hypothesis would be that most common favorite color is not purple. In research, we can only tell null hypothesis, and based on our data, we can say whether the null hypothesis was projected or whether it was failed to reject the null hypothesis. So we're looking to kind of disprove or evaluate it, right? So regardless of whether we reject or fail to reject the null, it is possible to fall into the appeal to ignorance logic fallacy. So let's continue with our favorite color example. Let's pretend that our study found evidence that purple is the most common favorite color. If this was the case, we would say that we reject the null hypothesis. However, it is common for people to interpret this result as proving that purple is the most common favorite color. This is a logic fallacy because in research, we can't ever prove anything to be true. We can only find evidence in favor of certain findings. So it's important to remember that even if a study finds significant results, it doesn't mean that their finding is proven. On the flip side, if our color study found evidence that purple is not the most common favorite color, then we could say that we fail to reject the null hypothesis. In this case, people may still fall into the appeal to ignorance fallacy by assuming that because we didn't find evidence in favor of purple being the most common color, that purple must not be the most common favorite color. Just because we didn't find the evidence to support our belief doesn't mean that the belief is incorrect. In research, there are many reasons we may not find significant results. For example, we may have had too small of a sample or used data collection or sampling methods that were flawed. So when you're reading the results of research studies, it's important to keep these ideas in mind. One, nothing in science can be definitively proven. And two, failure to find evidence does not mean that evidence doesn't exist. The larger context of research study needs to be considered in order to make judgments about the findings of a study. And this goes to a lot of facts, right? You'll see a lot of this ability to kind of fall between the cracks, and things change based on the ABCs, the attitudes, behaviors, and conditions and beliefs that people have within society, which also goes to, as we've seen, evidentiary things being changed, major studies being rejected or confirmed based upon shifting evidence that we now take into consideration. So, let's get a little further with this, shall we? Another type of logic fallacy is known as false dichotomy. This is when limited options are presented. often focusing on two extremes when, in fact, more possibilities exist. So by making a dichotomy, we get there. We see this with research when complex topics are oversimplified. For example, with the COVID vaccines, to keep a consistent theme, the false dichotomy between common narrative in the media. Social media claimed that if COVID vaccines worked, then no one who was vaccinated would get COVID. And if people vaccinated against COVID did contract COVID, then it means that the COVID vaccine didn't work. We saw a lot of that narrative. This is false dichotomy, oversimplified the complex topic and did not give credit to the research on the efficacy of the vaccines. It's important not to fall victim to this fallacy, and if you really need to dive deep into the research behind topics to understand the bigger picture, you need to. The false dichotomy can also occur when research findings are overgeneralized. For example, let's pretend a study found that football was the favorite sport to watch amongst teenagers. The logic fallacy here would be assuming that this means all teenagers prefer watching football. If we went to Europe and repeated the study, it's possible that soccer or another sport is preferred over American football. Due to fallacy, it's important that we take the sample into account when we interpret the results of our study. Another thing you can tie back to last lecture, right, is what if we just use the word football? And let's say we conduct the same study inside Europe, specifically the United or someplace like the United Kingdom. If we didn't adjust to the norms and the changes in our operational definition, we may be able to find that in our survey, so many people watched football, but would it be the football that we were talking about, right? So you see this ability to kind of manipulate data. So another fallacy people can fall into when interpreting research findings is the slippery slope fallacy. This is when someone believes that an action will lead to a chain of future events. With research, we see that people sometimes fall into this belief when interpreting the results of a study. For example, research shows that children of divorced parents are more likely to get divorced as adults. Someone falling into the slippery slope fallacy may read this finding and believe that because their parents are divorced, that all their future relationships are doomed, and that they'll inevitably end up divorced like their parents. This is the slippery slope belief because even though studies have shown that having divorced parents is correlated with getting a divorce yourself, it doesn't mean that this will happen. When interpreting studies, it's important to avoid slippery slope fallacy by remembering that even if something is statistically significant, it doesn't mean that it will happen to everyone. And this is a big one. I teach classes on masculinity studies, and when we're going over data and we're discussing rates of domestic abuse or violence within couple relationships, and you'll see a lot of heavy skewing towards men's violence against women, right? You'll have the statistics put out there, and you can see some crazy ones, so like 1 in 3 or 1 in 2. And I'll have two guys in the class who are asking a general question, being like, well, me and my friend don't do this, so therefore the data is incorrect. Or we're going to be doing this now since it's 1 and 2, right? It's not about that. And so you fall into these statistical issues where you fall into a slippery slope. It becomes very interesting to see how quickly you can have this. Another term for this outside in theory, right, is also the impact of a self-fulfilling prophecy. Whereas before it may not have been necessarily true because we can't claim everyone, because enough people have said it happened. You started believing it's going to happen, and then it happened. So let's go into a circular argument, right? So another logical fallacy is known as the circular argument fallacy. This occurs when a person's argument repeats what they assumed before. So the name's kind of self-explanatory. People who fall into the circular argument state their opinion as if it's a fact by just restating their original assumption about topic, right? We see this in research when people engage in what's called confirmation bias. There's a lot of research that's available for us to consume, so it's likely we find research that backs up our original beliefs. Confirmation bias is when we pay attention to research that backs our assumptions about a topic. This leads people to engage in circular argumentation because it results in them repeating their assumptions about a topic because they only viewed confirming evidence. It's important to avoid engaging in this circular argument fallacy by taking a broad look at the research findings on a topic and making an informed decision after examining the evidence behind both sides of said argument. So the next one that we're going to talk about is hasty generalizations. Now, hasty generalization is another type of logic fallacy that can occur when interpreting research. People make hasty generalizations when automatically believing a claim based upon a few examples rather than substantive evidence or substantial evidence, right? This is a fallacy because although a claim might be true in one case, it doesn't necessarily mean that it's always true. With regards to research, hasty generalizations may occur because there is a range of what is acceptable as sufficient evidence. In the social sciences, when we conduct statistical analyses, we often consider a finding significant if the p-value is less than 0.5 or 0.05, right? However, the value is somewhat arbitrary. What it really means is that we will find significant results when the results are not actually significant, less than 5% of the time. So essentially, there is less than 5% chance that the results of our study are wrong. That is why replication of the studies is more important, because the more studies that find a significant result for a topic, the more evidence we have to back up the claim rather than relying on only research of one study. So when interpreting research on a topic, it's important to look for similar findings across studies, avoiding engaging in these hasty generalizations. Another one here, the causal fallacy occurs when someone incorrectly makes assumptions about cause and effect. This occurs in research when people assume that because two variables are correlated, it means that one variable causes the other. In other words, correlation does not equal causation, something I've been talking about in the two other lectures that you just recently watched, right? You'll see a lot of these circumstances. If you haven't gone on Reddit, I'm always hesitant to say go on Reddit, but there's a lot of really cool and interesting examples of the fact that correlation does not equal causation, but you'll see some crazy statistical analyses with this, right? For example, as shown in the graph on the slide, the sales of organic food is correlated with the prevalence of autism. Just because the two variables are correlated does not mean that organic food causes autism. Instead, it is likely that confounding variables are responsible for the increase in organic food and the rates of autism. It's likely that autism diagnoses have increased as we've gained better understanding of autism and gained better tools for evaluating children who are impacted by this. At the same time, with the increase in information available, people have learned more about food industry and health, resulting in more people choosing to purchase organic foods over non-organic foods. It's important when interpreting research to not engage in the causal fallacy by remembering that just because two variables are correlated does not mean that one variable causes the other. So I encourage you, by the way, in this class, as we are learning about social science methods, go online and look up some crazy logic fallacies. And that'd be a cool thing to post on Yellow Dig. I hope you do, because I always think it's fun to see these like numeric and quantitative side-by-side comparisons and see if that is the cause or if that is the correlation and how we can break that down. So the last type of logic fallacy that we're going to discuss with regards to research is appeal to authority. This is one that I was mentioning with the kernel of truth, but this fallacy occurs when authority's opinions is misused to support an argument. This occurs when people believe opinions of someone who appears to be in a position of said authority, but when the authority may not necessarily have the evidence to back up their claims. A common example of this we see with regards to research and public figures is people like Dr. Oz, especially now, and Dr. Phil. People may fall into an appeal of authority fallacy when they automatically believe a topic that is discussed by one of these TV personas or personalities on their show. Just because they have a certain level of education and have their own TV show does not automatically mean that they're experts on the topics that they discuss in their show, right? This was a big deal. And again, back to my area of research, Dr. Phil sent a lot of people who were dealing with delinquent children into the troubled teen industry and made a show of it, right? They would bring them back, Bad Barbie, all the other ones, Bad Baby, right? Like, and these individuals were sent into places that he knew nothing about on the sense of how they worked or formed. It just was good TV, and people took it as a big deal, right? This is why experts on topics have to go through a rigorous peer review process when they submit research to journals to be published. The peer review process ensures that other experts in the field review the research and deem it acceptable to be published. The problem with authority figures like Dr. Oz or Dr. Phil is that the information that appears on their show does not have to go through a rigorous review process to ensure the only best research is based. Information is getting shared with the public. Due to this, it's important to do your own research when you hear information from authority figures. Go ahead and dive deeper into the topic and look at the information that published on that topic in a peer-reviewed journal. This way you don't fall into the appeal to authority fallacy and you come to your own conclusions instead of automatically believing the information shared by others. All of the logic fallacy we discuss in this lecture are important to keep in mind when you read and interpret research, that you can make informed decisions based upon research that you consume. And this one's a shorter lecture, but I'm hopefully going to see some of your great posts. I really encourage you to find some cool ideas of logic fallacies and definitely share these things on discussion boards, or you can email it to me. But that will bring this lecture to a conclusion, and I will see you in the next one.